Hi there, welcome to this new video of data science project, and in this video I will show you how you can tune the hyperparameters of a time series forecasting project. So far you have seen that in my previous video I have shown you how you can create a time series project from a scratch, how you can transform and normalize data, how you can put a lag and create lag variables and all for further processing of the data for within the time series. And in this video we will just continue our conversation about the time series, and we will look at the hyperparameters. So what are hyperparameters? Well, in a nutshell, if I tell you, so for that I'll just go above where I have my previous codes and for different projects. So this was for over here. If I go back, I'm just searching for, over here we have ARIMA model that we created. So over here, so if you look at the std_birth_train order equals to 212. So order 212 is the parameters that we had given in that video or in that project, and the hyperparameters are nothing but when we tune these parameters for different settings, like for example, instead of 212, let's say 110, 101, 111 or 211, 212, all of that different settings we try to change in a runtime and try to identify whether the model is working fine or not with those parameters. So this way we do an experimentation with a good combination of numbers on the entire on the train and test data, and then we figure it out whether the error is getting reduced in a particular type of setting or not, and then based on where the error is minimum we go ahead and select the model. So this way we basically try to identify the best model using the hyperparameter tuning. And the best part of this video will be that it's a complete automated procedure. Once you have written the code, you will just pass on the new data set or the new information as part of the time series data set, and it will start populating the information, like I have mentioned in the previous video about how you can automate the time series process. So you can see that and create a function which will automate your entire process. Alright, so let's go ahead in the end and try to start the work, and you will find the link of the data set as well as this worksheet into the description, so that you can go ahead and download, or you can follow along here with me with any other data set that you have it. Alright, so for the first thing is import pandas as pd, import matplotlib.pyplot as plt percentage. I don't think I will going to plot anything because that's something which I have already shown you. Here I will focus solely on the hyperparameter tuning. So for that I will import from the stat models models.tsa.arima model_arima. I guess I'm just trying to get the arima_model. Alright, import arima. So this one. Alright, so once we do that, we have the ARIMA model, and we need for evaluation of the model we need the metric, which is scikit-learn's mean squared error. We'll just take that metric, or we can basically take a square root of that using the numpy, which I have shown you in my previous video as well. So from scikit-learn, which is scikit-learn, just see scikit, just trying to get it auto-corrected by the Python, that is scikit-learn. I was writing it correct, just going ahead with what I pronounce. So scikit-learn.metrics import mean squared error. All right, so once we have done that, what we need to do is import the data set. So we will continue using the birth data set that we have been using from the previous video, and this I have explained multiple times, so I think we don't need to go again with this. Now the next thing is basically define the PDQ values in a range. So basically p underscore values, and let's say range from 1 to 8. This is what we want to change, or from maybe let's say 0 to 8 if something you want to start with 0, 1, 1 or 1, 0, 1 or things like that. P values, D values, we can say a range from 0 to 3. I think that is more than sufficient, and that's basically with the experience you will get, but yeah, 0 to 3 is more than fine. Q values equals to range maybe 0 to 5. Alright, so we have implemented the ranges. If you want to check p underscore values, you will see that it is the range of these values. After this, we will start defining our main script. That means we are directly jumping on the point over here, which I want to show you. So for that, we need to iterate over the p values. So I will say for p in p underscore values, right? After p, I want to iterate the d value because the second parameter is d. For d in d underscore values. The third loop we need is for q values. For q in q underscore values, right? So far what we have done is just define the 3 iterators, one for p, one for d, and one for q. So what we will take is we will go step by step of each value which is present here in the range, provided to the order which ARIMA model needs, so that ARIMA model can run multiple times without manual intervention or without manually specifying it, and then we can get the output of the mean squared error of each of the combination. And this way, from let's say 10, 15, 20 combination, we will see in which case the mean squared error is coming low. So the next thing is, let's define the order, which is p, d, and q, right? And once we have defined the order, we will create train and test. And for train and test, we will take f underscore birth, let's say 0 to 300, comma f underscore birth again, birth 300 to 365. All right, so now we have the order values combination over here. We have the train and test data set that we can pass it to our algorithm, and as we will going to fit the algorithm and do the prediction, we need to create one variable which is predictions of type list, in which we can store our predictions that we will compare later with the test variable. So we will see the data set which is unseen to the model, how it is doing it with the predictions, that is in comparison with the test. So once we have done the prediction, we need to go through one more loop which will run to fit the model and create the output for the mean squared error for I in range ln of test. And then, so before I move ahead, while length of test is because for each of the test value that we have, we want to have the similar number of predictions. Then only we will be able to make the comparison, so prediction will have the same number values as of test, and the prediction will store the values from this for loop. So that's why we are running with the same length of test. All right. So now let's go ahead and define our model. So model equals to ARIMA. ARIMA we have already specified it over here. So within ARIMA, we need to pass the data set, which is nothing but the train, and order is over here. So we'll just specify the order. After that, we will fit the model. So model underscore fit equals to model dot fit, and displacement equals to 0. Interview question I showed you in the very first video. If you have not watched that video, you need to go ahead and watch that to really understand it. And once we have fit the model, we can start doing the forecasting. So predicted y value model underscore fit dot forecast, and it's the first column which we need to pick. Now we have the prediction within this variable. So what we'll do is we will append the predictions. So it will have the similar number of values like the length, the test. So predictions dot append pred underscore y. So whatever value it is keeping here, it will append it, keep on appending it over here, so we can keep on storing the value. Now let's go ahead and figure it out, the error. So error equals to mean squared error, and we have test comma predictions, right? So this way we will get our error. Now let's print our model. Print ARIMA percentage as, because it's the string, comma MSE mean squared error equals to 0.2 floating value percentage over here to print the error. Sorry, first of all the model, which is order, because that's the order we will going to print, order comma error, right? Order will tell us for which order what is the error percentage. So I think that's what we basically need. And the last time when I executed it and when I was testing this entire script, it threw an error. So I just wanted to show you, in case if it throws the error again, then we have to put the try and catch. But for now, just because you are learning very first time, I have not put any try catch or try accept, but just wanted to show in case if any error is thrown, then how to handle that. And as well as what I observed is it was taking a lot of time to give the output. So let's go ahead and execute this and see the error. So over here, cannot cast unfunction float 64 to type with casting rule same kind. So it is coming over here, pred dot forecast y. Okay, so first let me just start with try. After this, let's just do the proper indentation, and over here try accept, and we'll just say continue. If you execute this, just the warning which is not a big issue. As you can see, it is still running, but what we are not getting is the print statement. So furthermore, yeah, so it's running, it's just that the print statement is not coming properly. So let me just try to go to kernel and say restart. The restart we will just have to do this entire process once again. Execute this. Oh, kernel restarting. All right, kernel is ready. So let's go ahead and execute this. Execute this. We don't need to execute this, but for print ARIMA, I think it is not picking up it as the one which it needs to interpret, because maybe I used the double quotation. Okay, accept, continue, and let's go ahead and execute this. still the similar error. Let me just quickly see where it is giving the problem. Yeah, as you can see, it is running. So I was getting this warning earlier as well. Alright, so I just paused the video just to revise the model. When I say revise, I mean to revisit the model. And just one thing which I checked is or one thing which I corrected is this percentage over here. Earlier it was over here, for example, not here but here, because of which it was giving the printing error, but the right way of putting it over here. So now you can see where I have just run the model, and ARIMA 001, 002, 003, 004 and their mean squared, respective mean square value. So you can see for 012 the mean square value is really amazing, 39. And if you have seen my previous video, it was somewhere around 49 or 50 or somewhere around that. So with this you can see that we have just seen how improved our result can be, and I just saw 39.71. so all of these values are getting printed, and as you can see that this is pretty heavy script, as it is taking a lot of time, and over here it is indicating that it is running. Similarly, you can see over here that something is going on in the backend for processing. And one more thing which I just added, because those warnings were looking really bad. So what I did is I just added this 2 lines, which is import warnings and warnings dot filter warnings. So with this we are able to produce the output, and as you can see it is running. And last time when I checked, it was running for some 8-10 minutes. As you can see, a new value is displayed over here. So all of these combinations will be tried, and you can see that you at the end of the day, you are getting the good output. So while it is running, maybe you can have a coffee like I just did. So that's about it in this video about how you can automate this entire process. And only this small mistake took a little bit of time just to figure it out what has happened, but yeah, apart from that everything is working fine. And you can see that for different variation you are picking up the model based on where the value is less for the mean squared error. So 39.71 is the only one which I can see right now is the minimum value. Not only this, you can also have something like some improvements, like the output that you are getting over here. You can put it in some sort of an order, or sort the values and sort the values by error, and this way you will get the first value once it is done. Let's say in the backend everything is done and you want to pick the minimum value, which is like the minimum score as the best model. Just sort the values by error and you will get the best output, or the best model based on the orders that you have specified. Right now it is 1 1 1. So there are a lot of other enhancements that you can do into this. The more you will dig into it, the more you will figure it out, okay, the next thing that you can do. But this is just the code to tell you how you will going to start with the with any hyperparameter tuning related activity in your project. And almost every project has this. So this way you can go ahead and do the hyperparameter tuning. So let me know how do you think about it, and I'll look forward to see your comments, as well as if you find it useful, go ahead and like it and share it with your colleagues and friends so that they will also become the data scientists like you, and you guys will have a great discussions on these codes and problems. So thank you for watching this video.